It shows. Let me get it. Okay. So, this is the next step in proof, CPCTC. All right? What it stands for. Corresponding parts of congruent triangles are congruent. Corresponding parts of the only time you'll need to know that is on notebook test. When it asks you what your CPCTC is. You just have to know what it's used for. When a problem asks you to prove segments or angles of a triangle are congruent, it is the step that directly follows your triangle congruency statement and theorem or postulate that justifies your statement. You're just going in this one.
What's up?
You're just going in. If you get yourself enough, shovel that way.
Yeah, but and you have, you just like feel it. It just doesn't feel right.
All right. All right. Part of this is a review from everything we did before the break. Number one, we state the given, which some people unfortunately did not do on the quiz and lost points. Number two, deductive reasoning. Number three, your congruency statement and postulate theorem. You need to write the whole word down, go right ahead. Number four is going to be CPCTC. And number five, which we'll focus on tomorrow, is to justify a definition of cost. I'll be in this room tomorrow. Extra help, most likely. So I'll be in this room tomorrow. I don't know what else. If you want to come to any lunch session, I have.
Me too. It's soft, honestly.
I'm gonna yell around back there. All right. So basically, the first three is what we just finished. CPCTC is what tells us segments or angles are congruent. Five is justify the definition or proposition. All right. When they ask you to prove and this is up to you if you want to add it or not. When it asks you to prove triangles are congruent, stop at 3. When it asks you to prove segments or angles are congruent, stop at 4. When it asks you to prove a definition of property, finish at step 5. Okay, we got time today. No quiz or test this week.
Oh, you are too fine.
Just reminding me how to do that. Step 5 in detail. The majority of step 5 will involve restating the true statement and then stating definition of. The majority of step 5 will involve restating the true statement and then stating definition of. with two exceptions.
I can text my mom. Okay.
Go right ahead. It's not like I'm here.
I'm just telling you.
Whatever. Good. Step 5 exceptions. Proving lines parallel. First, you prove angles congruent using CPCTC that are AIA, AEA, corresponding. You then state lines are parallel by this same property. And we will practice these tomorrow, like I said. The other exception is proving lines perpendicular. You'll need to prove adjacent angles that form a linear pair are congruent using CPCTC. You then state that the angles must be right angles by the linear pair property. State lines are perpendicular by definition of perpendicular lines. Good. All right. All right. So, the parts 4 and 5 can't be used until you do step 3. So step 3 involves proving the triangles are congruent. Just by looking at it, why are the two triangles congruent? There's your theorems of postulate. Which theorem of postulate? Angle, angle, side. So the two triangles are congruent by angle, angle, side. Because they're congruent, now we can say everything else in the triangle is also going to be what? Congruent. So for example, we can say RS is congruent to WX by CPCTC. All right? We can say that QS is congruent to TX by what? CPCTC. All right. We can also say what two angles are congruent. Q and T. Do we need CPCTC to do that? No. Of course, what's the other one? All right. So that's the idea behind it. All right. Now, one of the things we need to discuss, ladies and gentlemen. This is telling us angle X is congruent to angle Y. That does not mean that this smaller angle is congruent to that one and that one's congruent to that one. Does everybody understand that? Before moving forward, I just want to reiterate that. You can't assume the other angles are congruent. All right? Now, there's actually two sets of triangles that are congruent in this one. One of them, ABX and CBY. Again, going back to triangle proofs, what may be helpful in these? Drawing them what? Separately, right? So now A is congruent to C, AX is congruent to CY, And then why would those two angles be congruent, the ones found in P? Because of what property? Vertical angle property. Those two triangles would be congruent by what? Angle, angle, side. You could then say, for example, AB is congruent to BC, BX is congruent to BY, and such. Okay? Now, what we will discuss probably in the beginning of next week is the use of the reflexive property in overlapping triangles. In other words, AXY and CXY. All right? Both those triangles have what on the bottom? What segment? X, Y, X, Y. So that segment is exactly the thing. So we can say XY is congruent to XY by the reflexive property. All right? We already know AX is congruent to CY. And from the diagram, angles X and Y are what? Congruent. So those two triangles will be congruent by what? Side angle, side. And then we could say AY is congruent to CX by what 5 magic letters? CPCTC. We could go back here and label these congruent by what 5 magic letters? CPCTC. So in terms of proof, I'm not really doing much. I'm adding a step and the justification for that step is what 5 letters each step. What you have to then incorporate is, when do I need to go to that point? All right? And that's when he has to prove segments and angles of congruence. Everybody good? Disagreement.
What did you say?
Disagreement. Miss Falk, you ever watched the movie Christmas Vacation?
Oh my God, that's my favorite movie. Me too.
Congratulations, so proud.
I also watched.
Literally, according to some people, I turned the call.
Yeah, that's my dad.
Okay. Now, proof. Ladies and gentlemen, observation from the quiz number 2. Just because lines are parallel doesn't make them congruent. Right? Just because they're parallel doesn't make them congruent. Alright, so QS is parallel to RT, angle R is congruent to angle S. That's the given. On your quiz, ladies and gentlemen, one of them involved 3 given statements. That proof was worth 12 points. If you restated all 3 givens, you got 6 of the 12 points. Make sure you restate the givens. It seems like a silly point, but you have to do it. Now, as soon as you see parallel lines, you should recognize that those angles are going to be congruent. By what 3 magic letters? A-I-A. Now, here's the issue, ladies and gentlemen. Again, observation from the quiz. Why can we not call those angles Q and P? There's different angles. So your solution is either use how many letters? 3. Or some of you did this on the quiz, and that's great. Convert them over to what? No. 1, 2, 3, 4. Okay, now, with fill-ins, you have to go by what they say. All right, and since they're not telling us anything, we can get away with calling them numbers, which I think is easier. So there's 1, and there's 2. Angle 1 is congruent to angle 2 by alternate interior angles. All right. What do they have smack dab in the middle? Line segment. I'll work with you, but it's QT, shared side. So that's going to be congruent by what? Reflexive properties. So QT congruent to QT. I'm listening.
Would angle QTS be right because the line is just
Doesn't have to be. They have to give you information that says it is. They never tell you. They'd have to tell you the lines are what? Perpendicular or, all right? If they did that, so the lines are parallel, and they said that that one was 90 degrees, then that would have to be 90 degrees. Make sense? But they never mentioned anything like that. All right. So now, angle, side. So we have to list the triangles in order. All right? We have to list the triangles in order. So I'm going to call it triangle SQT is congruent to. Remember, order is important. S has 2, Q has 1, T has 0. I have to follow that same order. 2, 1, 0. So that would be what? R, T, Q. And then what do they ask me to prove? That angle QTS congruent to angle TQR by corresponding parts of congruent triangles are congruent. You are going to use CPCTC when you write that. Yes, ma'am.
Or we just put anything in the box at the top?
You could if you want. That's just walking you through the same thing. Up to you. All right. So, copy and mark the figure to show the given information. Explain how you would prove AB is congruent to DE. So, for number 4, all right, number 4, they say AC is congruent to BC, and angle B is congruent to angle B. All right. Now, the easiest way to do it, all right, because we have intersecting lines, is what kind of angles? Vertical angles. Vertical angle property. If I go ABC for the left, what order do I got to go on the right? EDC. Which theorem postulate am I going to use? Nope. Triangle, that's why we're going through it. Triangle's congruent, we go back to what? Either side, side, angle, side, angle, side, angle, angle, side. There you go. And then they ask me to prove AB is congruent to D.
Yeah.
What 5 letters are we going to use for that? CPCTC. Okay. Every proof can be different, depending upon the information they give you. So keeping that in mind, please do number 5. Keeping that in mind, please do number 5. Why are both pairs of segments congruent? Segments.
CP.
Even before that.
Vertical, definition of angle.
Doesn't have the angle, it just says
Bicep.
which one was? Everybody good with that?
Yep.
Then these angles are going to be congruent because of what?
Vertical.
Vertical angles. Triangles are congruent by which theorem or postulate? Right-hand side. And then AB is congruent to DE by what 5 magic letters? CPCTC. All right. Now, next up, AB is parallel to DE. AC is congruent to EC. All right. Now, AB is parallel to DE. Those angles are congruent by what 3 letters? A, I, alternate interior angles. All right. They say AC is equal to EC. Now you got choices. Choice 1 is what? Vertical angles if you like. Then the triangles will be congruent by what? Angle, side, angle. Or, here's the other route you go. These are alternate interior angles, ladies and gentlemen. And so are those. When you have parallel lines, you always have 2 pairs of alternate. Right? If you go that direction, then instead of angle, side, angle, it would be what? Angle, angle, side. And then, of course, AB would be congruent to DE by what 5 magic letters? CPCTC. In that diagram, ladies and gentlemen, these are always pretty much going to match up. Those are going to match up. Those are going to match up. All right? All good? All right. All right. So, GK is the perpendicular bisector of FH. Prove FG is congruent to HG. Go to work. Put it together. I will be in the 9-10 library today after school. Obviously, I'm vocally challenged. Well, try to submit this in Google Classroom. Well, all right. Now, I'm going to skip 2 for the moment and go down to 3. Because GKF is congruent to GKH. All right. Reflexive property is the shared side, so GK congruent to GK. All right. Perpendicular bisector, a lot of times we use the perpendicular part. Today we're going to use the bisector part. That means K is the midpoint. If you want to include that in your proof, go ahead, but it's not necessary. You can go right to FK congruent to KH. All right. You can't get away with that with the angles, because the definition of perpendicular bisector, perpendicular never includes congruent. Simply means right angle. Once I include that, why would the 2 triangles be congruent? What 3 letters? Side angle side. All right, and then we could say FG congruent to HG by CPCTC. Ladies and gentlemen, when using CPCTC, make sure your letters are in the same location in your triangle congruency table. They have to be. Otherwise, it's incorrect. All right. All right. The bottom one, you won't have this yet on the proof. We'll come to this in a second when we get back to chapter 6 in a while. But ABCE is a rectangle. All right. That means E and C are right angles. That's the definition of right angle. All right. They also include AE is congruent to BC. That's actually a property of a rectangle, but when we have to worry about that in chapter 6, we'll talk about it. All right. The fact that D is the midpoint of CE tells us what 2 segments are congruent. ED and DC. Definition of midpoint. What 5 letters are going to tell us AD is congruent to BD? CPCTC. Looking at my diagram, which 3 letters tell us the triangles are congruent? Side angle side. All right. And one thing you can do, ladies and gentlemen, to make sure you list this correctly is use the CPCT statement. So I'm going to say triangle AD, leave a little space, triangle BD. AD, where do I go next in the triangle? E. BD, where do I go next in the triangle? D. So you can actually use the CPCTC statement. Help you with the triangle keywords. All good? All right.
I noticed that was triangle, why wouldn't it be AED?
You can if you want. You're talking about 5? Yeah.
This one, huh?
As long as your A matches up with your 1, then your D matches up with your D, and your E matches up with your C. That's the same as it was before.
Or that's 4 numbers.
Hold on. Okay. So 1 and 2 are like the first one we did. You have to list the congruent statement and then list everything else that's congruent. All right. Feel free to add sketches. You don't have to explain why. So in other words, are these angles vertical angles? Yeah, so you can add them in. You don't have to explain that they're vertical angles with these. All right. 3 is a fill-in proof. 4 and 5 are 2 short pre-response proofs. Make sure you write them out. You can put that in any format you want. 2-column or flow chart. On the back, you have another fill-in proof, and you have 2 more open-ended proofs. All right? You have 2 more open-ended proofs. Again, it says to write a 2-column proof, but you can write it in any format you like.